Okay. Good morning, guys. Thank you for joining me today. We had two sessions on Spark. The first one was Introduction to Spark, Architecture of Spark, Process of Spark, and how Spark works on a distributed Hadoop cluster with parallel in-memory processing. The second video was on the transformations that make Spark work. There are different transformations which we have covered, and today we know what is an RDD, we know what is the transformation, how they work with RDDs, and we also discussed about pair RDDs or key value RDDs. So today we are going to move on to the next level in expanding our wings to understand the other areas of Spark, like Spark streaming, real-time streaming, and the other leftover Spark transformations. um, I would like to make you the architecture clear, and then I also wanted to show you practically the same thing. Okay, let me start my session now. So today we are going to talk about pair RDD operations. We have 1 second. If you see this, we have clearly talked it to this point, that is map values. I have shown you what exactly map values does. Okay, wherein it works on only values in a pair RDD while leaving the keys unchanged. There will be situations where your key can be idle and the transformation has to be applied only value. There are different scenarios. Understanding different scenarios or
My
forecasting.
screen is not visible.
Are you sure? Oh, thank you. Thank you. Sorry for that. Hope you're able to see my screen now. So this one we have covered in our last session. Okay, today I'm going to take it to the next level of pair RDD operations. Transformations we have done, operations we'll be discussing today, and followed by the Spark streaming. Okay, any questions you can raise your hand. Pair RDD operations. Now the first important bit, somebody has asked me, Amar, how do you swap keys and values? That's the agenda here. It's coming over here now. Okay, reorder key value pairs is nothing but, or reorder key value pairs using a map operation. Your key becomes value, your value becomes key. This is explained in this way. To reorder the placement of elements in the key value pairs, you can use pattern matching available via map function. Pattern matching is very important, very important. It will be used at least once in any of the code. Real-time code, pattern matching, you have to be using it because to verify your results before you go to next level. Okay, let's look at an example. You have an example demonstrating it, how to take a simple pair RDD and switch the order such that key will become a value, value becomes a key. Now let's understand where is it useful. This is useful when you want to use a function that is designed to work only on a key. For example, sort by key function, but have it applied on the value instead. Sort by key sorts all the results with reference to the key. But here what we are doing is we are applying a reordering of key value pairs and transition on the map, transition on the key rather than value. Basically what happens is sort by key is working on function. Sort by key is working on basis of key. You are swapping your key to value, value and key. So you are sorting by key actually on the value by changing it. Let's have a look how we can do that. Okay, so first thing I'll launch PySpark. I'll take one of the RDD, which can be anything. I have to parallelize them to make them a data set, PARALLEL. As I told you very clearly, why we use curly brackets, why we use square brackets and circle brackets. First, I'll have a data set called cat. Anything is fine, and then I'll have a value of 0. This is one data set, and the second data set will be A, and then I'll have 1. Afterwards I'll have spoon if I wanted. This is done, and then 2. What I must be doing is closing this one here, closing this one here. Okay, let's see how many brackets we had. Yeah, did we have the proper quotation? Yes, we have it. Syntax error. 1 second. Yeah, there is one small mistake. I don't want this here. Okay guys, very simple. Let me show you very clearly. This is one element. Okay, this is another element, this is another element. Each element starts and closes with a circle bracket, okay, followed by the square brackets. I have shown you very clearly what is the difference you have when you use square bracket and circle bracket. This is the indentation and the way how Spark reads your data when you create a key value page or when you create an RDD. If you have any questions, let me know. Now it has taken perfectly. Now what I'll do is I'll ask Spark to go ahead and reorder it. Reordering it is very simple. Let me show it. RDD reordering is equal to, I'll apply the function on my main thing, which is this one, and I'll apply a map function on top of it. I'll also apply a lambda function, which is a basic requirement. Lambda function is my anonymous function here, and now I have a key and a value which will become value comma key. Value comma key. That's it. Fairly simple. No further confusions. Zip spelling mistake. Let me check that. Zip VIR, not VIP. VIR. I'm just following the slides. No, I'm not doing anything. I'm just following the slides and showing you how we are implementing the swapping of keys and values to values and keys. Okay, now it has taken. Let me show that. Reorder dot collect statement. RDD, spelling mistake again, sorry for that. O is uppercase. Okay, now if you see my input carefully, cat is key, 0 is value, A is key, 1 is value, spoon is key, 2 is value. But what I have here, cat has key 0 has become key, cat has become value, 1 has become key, A has become value, 2 has become key, spoon has become value. So this way we are going to change values to keys, keys to values. Now let's approach the same process or same scenario in a different way. Okay, I'll take two key to values, means I'll take what we call I'll take numbers now. Okay, we had int right, we had strings. Now I'll take numbers. This one is first thing, cross brackets, and then inside you'll have square brackets, and now within each one you create a data set. So my first data set will be cat, followed by I'll have 0, 1. Now as I told you earlier guys, you can use keys and values. You can also use key and list of values. Now I'm going to show you a scenario with key and list of values. 0, 1 is my list of values. So this is my first element in the data set. Now what happens is this one is completed. Be careful and close the bracket here. This is done. So what happens next is I'll take a different data element within the data set that I'll give as spoon. Okay, spoon, and close this one. Once you close this, you'll have to start a new list of values, which becomes 2, 3. Close this one and also close this one. That's it. Okay, now let's see if our indentation is correct. Yes, it is correct. Now guys, you have carefully observed. Earlier I have given one key, one value. I made value to key. Here I am giving one key and list of values. I have very clearly told you key values can be changed to list string of arrays. Key values can be changed to key and list of values, and later you can also convert them into tuples. If you are dealing with key and list of values, your indentation starts from 0. If you're talking with tuples, your indentation starts from _1, means reading the elements in the RDD. Now what we are going to do is we are going to change key to value, value to key. Let's see that how we will do for this one, because here you have two values. There you have only one value. You just did key to value, value to key. Now we have two values. Let's approach how we can do that one. I'll keep it simple. I don't want to complicate it. Reorder. I'm applying this on RDD key to val because I have two values, and this is my second statement. And for that one you have to apply a map function, because we are talking a map function scenario, and you have a lambda function. Very good. In here what happens is, be careful, I'm using this one because I'm sorry, I have to use this one because I have a key and list of values. So this is key statement, followed by you have two values. One is value 1 comma value 2. Close this bracket. This is done. Now that becomes your key comma value 1, and then you have value 2 statement. Spelling mistake. Once again, this one is this. 0 and 1 is value 1 comma value 2. It's not dot, value 2. This syntactical structure is now changed to key comma value 1 and value 2. So cat comma 0 becomes key and 1 becomes value. Okay, let us see that. Perfect. I have to do parallelize. I haven't done that. Good one. Give me a minute. I'll show you that one also. So with this way, let's check syntax error. Closing bracket problem. How many brackets did I open? This one. Yeah, this one should be open here. Your lambda function started from here. Your key started from here. So let me close this one. This is wrong. So what I have to do is, once again guys, there's one small mistake in the whole funda. Yeah, one last one should be there. Invalid syntax. 1 minute. Lambda key value 1 value 2 key dot value 1 value 2. 1 second, give me a second. Lambda function is fine, key function fine, value 1 value 2 is fine. So let me do it once again. You have a key and a value. Let me check the syntax correctly if I have done it right. Let me check my slides actually. That will show you everything. RDD key to value lambda. That's correct. It's perfectly correct. Okay, once again, let me try doing it again because there is somewhere I have done a small mistake. So I have lambda function, and then first let me parallelize it and then do it. Okay, let me parallelize this one. Okay, this is done perfectly. Now simply what I'll do is, for this one I'll recheck it. RDD key to val dot map, which is perfect. Your lambda function starts the bracket, which is perfect, and you have to initiate your key, which is with the bracket start, perfect. Value 1, value 2, perfect. You have one bracket close, and you have to close the lambda bracket also. Okay, this bracket is for this one. Okay, and this one is for this one, like that. Now this is where I messed up. I got it. Now I'll have a key and a value 1. After that I'll take comma value 2. This is where I have to close the bracket. Now it took correctly. Do you understand the mistake what I have done? This extra bracket along with the improper bracket closure. Okay, once again let me tell you, don't confuse yourselves. This is quite common. Okay, this one we have been discussing. After map function you have an anonymous lambda function, and you initiate a variable, and anything after variable will be this one, that is for a transformation. For here we are doing an operation. Okay, this is key, this is value, and this key, this value should be working like this, like this key and this value. Okay, now let's see reorder dot collect statement. So cat comma 0 became key, 1 became value, spoon comma 2 became key, and 3 became value. Okay, that is what it is. This is how you can convert or shift maps to keys to values. You can use a map operation to shift keys to values to key. Hope everybody is happy with this one. Let me go to next slide. Here we are talking about keys, values, and sort by key. Okay, keys, values, and sort by key means some common functions to call when working with key pair RDDs includes keys, values, and sort by key. Okay, we'll explore them using RDD map value. One second guys, just a second. One minute. Okay, that's all sorted. Now this common keys value sort by key will work on a scenario to scenario basis. So what you have to understand is your keys will just return at just a list of keys in your RDD without any values. Sort by key, try to understand, don't get confused. Sort by key is fairly simple. Sorting your keys in an ascending order if it is set, if ascending is set to true, it will sort from small to large. If ascending is explicitly set to false, it orders from largest to smallest based on your key, not in value. It takes key as a reference, and it shows the results in an ascending order if your ascending is set to true when you give sort by key. Okay, now let's go and see the example of keys, values and sort by key. Here if you see my example, I've clearly shown you how I am adding map values and how I am collecting those results. Let me show you that example. Let me first see this one. This is my whole RDD which I have been using now. On this RDD I am applying map vals, which means apply the transformation only on values. Okay, I have used this transformation, anonymous lambda function. I have a value and I'm asking to apply 1 on every value. This is collecting the statement, which is perfectly alright. Now I'll also show you how I apply sort by key for this one. Okay, now once this is done, let's go to next slide because that slide also has the same content. Now before understanding that one, before understanding lookup, count by key and collect as map, let's finalize and conclude our understanding with practicals. Okay, let me come back. Now here I'll take same RDD. I can just do an up statement by copying and pasting, but the reason why I'm doing it is I want you to see it as many times as possible so it gets fed in your mind. I can just do an up arrow so that everything will come what I have used earlier. The only reason I'm not doing it, I have a reason for it. This is my first data set. You know this one very well, and my second data set will be like this, which I give a and then I give 1 as a value. Okay, this is done, comma, and then I have other one, spoon, and then I have an other thing called 3. So these are the set of my RDDs containing elements. Okay, which is perfect. Now I'm going to apply map vals. RDD map vals, which is nothing but you'll have to apply this function on the zip where RDD. Okay, on top of it you have map values. There you have lambda function, you have a variable initialization, and you are going to apply 1 on your variable. Okay, this is what it is. Now let me show you RDD map vals dot collect statement. Do you see that? You got cat A, cat 1 is added 1 to cat. Okay, it added 2 to A, it added 1 to AA, so it became 2. It added 1 to spoon, it became 4. Now let me show you something. RDD dot collect. It has given me only keys. It has not given me any values. Okay. Now let me see values. It has given me only values. Okay. It has not given me keys. This is how you can understand, work, and visualize your theory in line with your practicals. Okay. Now sort by key also I'll show you little later. Little later. But not now, because the point is sort by key has an interconnectivity with reduce by key and group by key. Okay, once we come there I'll show you that. Okay, I hope everybody is happy to this point. Let me move on. Now lookup, count by key, and collection as map. Here the basic difference from the things we have learned previous slide and this slide will be more or less the same, but a small difference which is with the way your RDDs are read. There are many other functions available for pair RDD transformations and actions. We'll go back to the key RDD example created earlier to discuss lookup, count by key, and collection as map. Okay, lookup key returns a list of values for a given key. Okay, not for everything, for a given key. Count by key returns a count of number of times each key appears in the RDD. So there were no duplicate keys. Your result will be different. Collect as map collects the result as a map. Result as a map will show you something which I'll explain you right now. Once again, we are going to we are going to see lookup key, count by key, collect as map. Lookup key returns list of all values for a given key. Okay, and also it also gives list of all values for a given key provided as many as values you have. Count by key, it returns count of number of times each key appears in RDD. If your key appears 2 times, it shows 2 times. If it appears 3 times, it shows 3 times. It shows how many times that is shown. Okay, collecting as a map, all your results of your transformation will be shown as a map. Let's go and do that one. Now I'm using a different scenario now. RDD to num list. This is very thing which we are using. sc.parallelize. Okay, this one is very important. I repeatedly telling this because you need to be very careful when you do this one. Okay, 1 2 3. This is one element in a data set, and I have 7 and 8, which is another element in the data set. Okay, this is perfect. Now let me show you. I do a transformation called key by RDD. For this transformation, I am applying on RDD to num list. Okay, in here what I'm doing is I'm using key by. In key by I wanted to check length. Okay, so now what it will do is key by spelling mistake. Sorry, it should be small b. It should be small k. Always transformations, the first letter will be smaller case. Be careful about that. Okay, now key by RDD dot collect. Now guys, you gave this is one element in data set, this is one element in data set. You are telling take the length of each element. Okay, that length should be key and this should be value. Okay, so length is 3 because 1 2 3, you have 3 elements. Okay, in that data set that became key, and the elements became value. You have 7 and 8 which became key and elements became value. So now this is how you can understand the usage of your lookup. Now I'll show you lookup. This is by key operation. Okay, now let me show you how lookup works. What is the statement I have used? I'm just looking for this one. yeah, key by RDD. If you see key by RDD dot lookup of 2, okay, 7 and 8. The reason why it is showing 7 and 8 is this is 1, this is 2. What you have shown, you have asked it to show lookup of 2. What did I say lookup means? Lookup will just return all the values for a given key. Which key did you ask? You asked for second key. Which one is second key? This one. What are the values for second one? 7 and 8. Okay, that is what it is. Okay, clear everyone? Any questions? Now this way we have finished lookup by key. Now let's also try count by key. Key by RDD dot count by key. Do you see that? Do you see why it came as default? Is it type in 2 1 2 is to 1 3 is to 1? Guys, it has returned count of the number of times each key appeared in the RDD. Okay, there were no duplicate keys, so it returned like that. If there were duplicates, that would have been different. Let me show you. I want to make things very clear. Okay, now if you see uh, count by key, okay, how many keys do you had? You had only one key, and you also had in one key you had 3 values. Okay, in other key you had 2 values. That is what this guy is showing here. Okay, fairly simple. It is just counting by key, means how many times each key appeared in the RDD. Okay, now let's see correct as map. Not this one, not at all this one. Let me, what is the name I have used there? Key by RDD, right? Key by RDD dot collect as map. See, 2 is 7 comma 8 comma 8, 3 is 1 comma 2 comma 3. What it is telling is collecting the results as a map. Guys, first time we are seeing curly brackets. First time we are seeing curly brackets. Now it is not a key, it is not a list of values, it is something different, which I'll show little later. It's a question mark for you, everyone now. Forget about it. Collect as map is nothing but the transformations results will be shown as a map. Okay. However, if you see, 1 minute. If you see here, your key is 3, value is 1 2 3. Your key is 2, value is 7 and 8. Okay. But when you collect as map, this 2 colon 7 comma 8 came up, comma 3 colon 1 comma 2 comma 3 came up. That is because if multiple values exist for the same keys, only one will be returned. If you see no example, we don't have any multiple values, we have unique values. For that reason, it is returning as a map. What is a map? Map contains keys and values. So this one is key, this one is value. This one is key, this one is value. But this one difference, this one represents that your key value changed to key and list of values, and furthermore what that furthermore is called as tuples, which we'll talk little later. Okay, everybody clear to this point? Now let me go to next thing, reduce by key. Very important. Now if you understand this one, you will be able to clearly write one of the certificate question perfectly, because it's most expected thing we use more often in our work life. Okay, try to understand it very carefully. Reduce by key. Reduce by key performs a reduce operation. I'm sorry for the yawning. Reduce by key function performs a reduce operation on all elements of the key value pair that share a key. That share a key means you have one key and you have list of values. As I told you, reduce by key keeps adding, keeps adding, keeps adding until and unless you come to a point where you finally have one value. Okay, let's take an example. And here we will be returning a key value RDD that was created using the following code. Okay, let me show you that. The reduce by key function goes through element, and if it sees a key that it has not already encoded, it adds to the list and records the value as is. Okay, for example, what I wanted to highlight here is, guys, focus, guys, please focus, very important. It's a logical understanding. 1, 2, 3, 4, 5, 6. Okay, first one starts with 0. Okay, 0 plus 1, 1. 1 plus 2, 3. 3 plus 3, 6. 6 plus 4, 10. 10 plus 5, 15. 15 plus 6, 21. Till here we are fine. These are all values. The first value always starts with 0. Okay, now you know you are doing val plus 1. 0 plus 1 is 1. 1 becomes a new value. Okay, so 2 plus 1 is 3. Now 3 becomes a new value. Okay, 3 plus 3 is 6. Okay, now this 3 and this 3, 6 becomes a new value. 6 plus 4, 10 becomes a new value. Like that, like that. You keep adding a plus b, means a is your 0 at the first stage and a becomes result of the summation. That's how you keep cascading it. That's the reason why he told here reduce by key function goes through element, and if it sees a key that it has already encountered, it adds it to the list and records the value. Okay, in such case, if I have again 3 here, okay, 21 plus 3 is 25. That is fine. But I have 3 here. I have 3 here. It remembers this information in the cache so that while doing the last phase of the current transformation, current operation, it ensures that this both should be 1. Now, there are two scenarios here. If you are just adding 1 to each key, each value, it's not a problem. But if you are adding 1 plus 2 plus 3 plus 4 plus 5 like that, then that will be a problem. That is the reason where we discussed commutative and associative. I want you to recollect those topics now. Okay, let me move on. Once again, the reason why I told you and the reason why I underlined the statement here is you have to be very clear that definitely you will see duplicate values, definitely you will see repeated values. When that repeated values comes, if a reduce by key is operated on that one, it first goes through each element, and if it sees a key that hasn't already encountered, if it is not encountered, then it is a new. It adds it to the list and records the value. That is fine. But if a duplicate key is found, reduce by key performs a function on the key values and keeps the number of keys to 1. Okay, Once again, try to understand. There is nothing to worry if your key is completely new. If your key is duplicated, or if the same key is used in the data element or data set, in such cases, reduceByKey performs a function on the key values, okay, keeping the number of keys to 1. Okay, in that case, all the duplicate keys, all the keys that are repeated will be transformed at the last step before giving the results. That is the reason why whichever key came as duplicate, you all come this side. How many times you have come? 1 2 3 4. So you have come 3 times, so you have this many keys. So for this many keys you have 3 times, so 3 duplicates. Let me put all the duplicates as 1. Okay, that is how it understands. I'll show you this practically, don't worry. Now the actual function is, okay, and other example is the anonymous function lambda a plus b only kicks in if duplicate key is found. If duplicate key is not found, it just doesn't work straight away. If so, the anonymous function tells reduceByKey to take values of two keys A and B and then add them together to compute a new value of the now reduced key. We have did it earlier and we'll do it today also. The actual function is being performed is up to the developer, but incrementally adding values to be the fairly common task throughout your transformation functions. Okay, where are we? Where is my slide? Let me close this one. Don't save. Done deal. Okay. Now let me show you something. RDD Amarnath equal to sc.text file user do dot works Amarnath.txt. Perfect. RDD Amarnath.collect. Let me verify the data before I move. Okay, perfectly fine. Now I am applying a flat map. I am applying a flat RDD flat equal to RDD Amarnath dot flat map. When you apply a flat map, we have a lambda function, and you split the line with space as characters. Okay, this is perfect. Now RDD flat dot collect, just to verify before you go. Perfect, it has taken correctly. Now I make it as a key value RDD, so that key value RDD will be RDD flat dot map function. You have a lambda function, and in the lambda function you have word, and your word will have word comma 1. Okay, now let's see the spelling mistake. This shouldn't be here, sorry for that. Word comma 1. Now let's see kvRdd dot collect. Now every word it has taken 111. Perfect, which is perfectly alright. Now here let's understand what your reduceByKey will do. Everyone focus, guys, everyone focus. I want to reiterate what I have told you. Please focus, please focus. Now let me come back to my statement. I'm talking about this one. I'm talking about this one. The reduceByKey function goes to the element, and if it sees a key that has not already encountered, it adds it to the list and records the value as is. I'm happy. This is what I want. Now if a duplicate key is found, reduceByKey performs a function on the key values and keeps the number of keys to 1. Once again, if a duplicate key is found, reduceByKey performs a function on key values and keeps the number of keys to 1. Now let me show you that. That's where I'm coming from. Okay, now I'll take this one, Amarnath, wait, Amarnath one time. Okay, is one time, is one time. Okay, so here guys observe, all the keys are different. This key and this key are repeated. So it repeated one time, 1. It repeated 2 times, 1. What is 1 plus 1? 2. Okay, now, and here first time it came up, which is perfectly fine. And is key, 1 is value. It counts plus 0 to your 1, which is 1. Okay, now let me check for other AND here. I have other AND here. Okay, which is 1 here, and also 0 plus 1, 1 here. So what is 1 plus 1? 2. Isn't it? Isn't it? Now let me show you something. Don't get confused. If you are confused, let me know. I can explain you once again. Okay, that is my fault. That's completely my fault. Okay, now let's see. kv reduced.collect. Do you see your AND came 2 times? Okay, and your is came 2 times. Rest all are 1 time, because as the key has not been read earlier, it just recorded key and value as is. If a duplicate is found, for every duplicate entry it marks 1 and then counts at the last. So is 1 time, is again 1 time, so finally is 1 plus 1 is 2, and 1 time again and 1 time, so 1 plus 1 is 2. That is how the whole funda works. Okay, happy everyone with this explanation? Any questions, any doubts? If you see here, what's happening in the elements of RDD are being recorded and passed to new key value called kvRdd. Mary and Lamb, which were founded twice. All other value remains unchanged, but now Mary and Lamb are reduced to a single key, each of the value 2. So Mary is your key, 2 is value, Lamb is your key, 2 is value. All other were unchanged because the key of that one has not been repeated. If the key is repeated, then that from that moment it starts counting based on its earlier collection. Clear? I hope everybody is clear with this explanation. Let me move on. Group by key. This is one other transformation which has a small difference from reduce by key. So grouping values by key allows us to aggregate values based on a key. Okay, Amarnath, how many ones we have? 1 1 1 1 1. It's a group. Sunil, how many ones we have? Sunil, 1 1 1 1 1, group of values. Krishna Chaitanya is the key. How many group of values he has? 1 1 1 1 1. That is grouping. We are not counting, we are just grouping. Please be very clear on that one. Okay, now in here, in order to see this grouping, the results must be turned into list before being collected. Once again, please This one line makes the whole difference in your key values to key and list of values and your tuples. So in group by key, in order for you to see the grouping, your results must be turned into list of list. That way I'll show you. Now here I'm going to use the same example. Okay, in this example I'm going to use group by key, which will group all my values that has the same key but an iterable object. Okay, now I have to use map function as a basic because first it has to read those records. Let me show you that. Okay, let me tell you theory completely and then I'll show you the practical part. Okay, everyone. Now here I'm going to use this one. While I use this one, what I'm going to do is, when you try to understand the logic part of it, please, when you apply, I'm talking about this one, when you apply group by key to group all values that have same key in an iterable object, that is by its own unable to be viewed. You will not be see it until unless you provide a collect statement, and then use a map function to define these grouped elements, okay, to readable list. First you will not be able to see them. Okay, you apply a map function to define these grouped elements in a readable format. That is what we are doing. That is the only reason why we use map function for group by key. Group by key can group it, okay, but this line says you, this line says the results must be turned into a list. That list must be readable. To turn that list into readable, you apply map function. Okay, that is what the whole funda I was trying to explain. Now let me go to next slide. Now if we had simply generated output using group by key alone, the result will be below. This tells you that results are an object which allows iteration. We know that iteration, what is iteration, we know it very well, but does not display the individual elements by default. Yes, it is not displaying by default until and unless you use a map function to read the list of iterables. Using map to list the elements, perform the necessary iteration to be able to see the desired results. Perfect. Now when we ran the code to collect the results, the output would look like this. Okay, like this. Where am I? Okay, now when I say looks like this, mean this one iterable. Okay, result iterable object at this one and this one. I'll show you that. Now the basic difference you need to understand is group by key and reduce by key functions have significant overlap and similar capabilities. Group by key is just grouping, reduce by key is grouping and then adding. Okay, but depending how on the called function is defined by developer, when either is to able to get the desired output. It is always better to use reduce by key as it is more efficient over large data sets. Okay, so one thing I want to tell you here is just I'm diverting from the topic. First we are trying to understand how each transformation works, how you can tweak the data sets, how you can change the type of data sets, how you can change to key to value, value to key, key to list of values, and ascending, descending, sort by, group by, and all those things. Once we are clear with that one, we will go ahead and work on doing the practicals for the complex transformations. That is the reason why I'm spending adequate time on Spark, but so that it reaches very nicely, you remember theoretically and also practically. Okay, that is what the point is. Now if you understand the difference between group by key and reduce by key, they both are fairly same with the functionality part of it, but reduce by key is more efficient than group by key. Let me delete this one and go to my practicals part. Any questions, please stop me. I'm happy to explain you. Now I'll do the same thing. I'll be a little fast now because you know what I have done. Okay, we know this. Now we apply a flat function to flatten the data. Sorry, I have to close the bracket, which is fine now. Fairly simple and straightforward, which is good. Now we are going to apply group by key. Now I'll go and use kv group by key equal to kvRDD dot. Okay, if you see here carefully guys, if you see here, it has said I have taken the input format like this. Okay, now let me show you dot collect. I have to give kb group by key. Okay, kb, that's kv is spelling mistake, but that is fine. Dot collect. Let me do it once again. Okay, now which is fairly okay. Now when we ran the code to collect the results, the output should be looking like the format, right? Let me show you that one also. Dot collect statement. Where is it? Why the results are not showing up? It has to show the result. It has taken it correctly. Let me do it once again. They should.
You assign the result to KV group again. Okay.
No, parallelize is done actually. Parallelize is not. sc.text file is same as parallelize. sc.text file is same as parallelize. Okay, guys, I'm sorry. This is a text format. My syntax is a problem here. Grouping by key. You have Amarnath. You have Amarnath, Ease, Vas. You have like that, right? For that one, when it is grouping by key, it has to group Amarnath 1,1 and give you the result. Okay, I thought we had integers. That is a problem. Let me do that once again. Okay, RD Amarnath is fine. I'm applying a flat, so that flat map, it will split by line. This is the problem. I haven't closed the lambda function there. Now it will give me the result. Flat is done. Now kvRDD. Perfect. On top of this, you will apply group by key. Okay. I'll change the name this one. Now let me see kvRDD.collect, which is perfectly fine. Okay. Now if you see kvRDD group by key. Okay. Now let me see. Okay. kvg.collect. Do you see that? Do you see that? That's what I've shown you here, right? Your output will look like this. Okay. Do you see that? My output is like that. One thing you have to highlight here is, guys, focus everyone, please look at my screen carefully one time. Okay. It started retrievable object at here, and you have training. Okay. You have they. Okay. We have Amarnath. Okay, like that every time it is using to identify it. This one will be seen at every key. Here also you have it, which means that is how it categorizes your grouping of keys. Okay, now let me flat map values, subtract by key, pair RDD joins. Guys, can you give me just 2 minutes? I'll come back. Are you clear to this point, everyone? Are you clear to this point? Any questions? Any questions? Let me know. Funny, any questions? Are you clear, Funny? Very clear, everyone? All the 13 attendees? Radhika, Shailaja, Swapna, Suresh, Varun, Benazir. Okay, thank you. Give me 1 second. I'll just come back. Just 1 second. Okay, I'm back now. So we have two more slides. We will be done for the day. Bear with me for two more slides. Okay, that's what it is. So let me delete off everything. Perfect. Let me go back here. Now this is perfect. We have finished it successfully. Let me go back to the next one. Flat map values. This is also kind of the one which we discussed few minutes back. Like map values function, your flat map values function performs a function on pair RDD values, leaving the keys unchanged. Okay, but there's one small difference here which you need to understand. However, in the event it encounters a key that has multiple values, it flattens those individual key value pairs, meaning no key will have more than one value, but you'll end up with duplicates in the RDD. Okay, now guys, one thing I want to make you understand is uh, while you list or while you read key value pair, your approach must be little different. When you approach key with list of values, that is different, and when you approach key and multiple list of string of arrays with curly brackets, that should be different. Okay, for example, if you apply group by key, have a lambda function and take a list of your things, that will be little different. Once again I repeat, like the map values function, let me show you map values function if you not remember that, this one. Okay, I've shown you map values very clearly, wherein this one is performing an operation on the values in a paired RDD with keys unchanged. The same like map values, you have flat map values. This flat map values, what it does is it applies a function on paired RDD values, not values, means you have one key and list of values. Okay, in this case if it encounters a key that has multiple values, okay, then it flattens those multiple keys, okay, or individual key value pairs, meaning no key will have more than one value. Okay, all the duplicates. Okay, once again, if I have confused you, let me be very clear. If the statement is confusing, let us clear that. When you have a key with multiple values, that individual key value pairs will be flattened in such a way that no key will have more than one value, means your flat map values will interpret that I have been seeing this key a number of times. So as and also this key has got multiple values. Let me now just imagine in my picture that I'm not going to process any key that will have more than one value. So it marks an entry telling in my whole data set there are few key value pairs that has got so many values. For that one I'll consider it as only one value. So that one value will be at reading phase, and once you apply transformation, that will be a different way of approaching it. Am I clear how flat map values works, everyone? Let me show you that also. So what example are we using? We were using Mary and lambda. That's fine. I'll use the same statement, which is to we have fine till this point. I don't know. I'll use a new one. Okay. Where is my RDD Amarnath sc.txt file? Perfect. And after that, what did I use? I have to put one for everything. split, which is fine, and then add 1 to every word. This is fine. Now here the key comes. Okay, in this one what I'm going to do is RDD flat map vals equal to kvRDD dot flat map values. I have a lambda function and I have a val. For that one I'll also have a val. Okay, now RD flat map vals dot collect. It kicked me because int object is not iterable, which is fine, and int object is not iterable. I got that. Where did I do? Okay. No, let me see if it is taken correctly. kvRdd dot collect. Okay, this is taken correctly. Now if I apply RDD flat map vals, guys, time is 6:20. I know that. We'll wind up in 5 minutes. Okay, so you have kvRdd, in that you have flat map values, you have lambda function, you have value space value. There seems to be some syntax error. I'll have a look on this one. Leave it with me. There is a syntax error. I'm sure about it. There is a syntax error. Forget it. This one I'll come back and have a look. Okay. This is done, and we are talking about this one. We know the anonymous function simply returns original unedited value. Okay, and however, like map values function, the flat map values function can be configured to modify the keys as it flattens or the key value pairs. For example, if we have, let me do it this way. Let me do it this way. Value plus 1. Correct. No, it's not taking it. Let me take it out. I'm just trying to understand different permutations. It gives an argument. That's fine. I'll sort it out later. Don't worry. Okay. However, if we had defined an anonymous function as lambda val plus 1, each count of value would have been written to 1 instead of, it will be 2 instead of 1, because it applies a 1 on top of it. Okay. That is what it is. Flat map values, bear with me. I'll correct the syntax and come back to you tomorrow. Okay. So subtract by key. Subtract by key just does a very simple thing. It verifies your first data set with second data set, okay, and gives you keys that are not found. always, please be informed, it verifies first one with second one. Okay, in this example, cat A and spoon, cat cradle spoon, cat A spoon, cat cradle spoon. Cradle is not there in the first one, cradle is there only in the second one. That's the reason why it gives cradle.9. Okay, to explain your theory, the subtract by key function will return key value pairs containing key not found in other RDD. Okay, okay, key, 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 key. This is found, this is found, this is found, this is not found, this is found, this is found. So here cradle comma 9 is result because it subtracted this one from this one and it found cradle is completely new. That is what it is. Okay, now what I wanted to tell you is, let me go to second one also. Now note a comma 1 was written as part of result. This is because there is one line I missed here. Okay, that one line is this one. This should be coming up. This must be coming up here. Okay, the note a comma 1 was written as a part of result is because subtract by key is only evaluating matches in the first RDD as compared to second one. If you see here, this is subtract by key of RDD.song. Okay, if you go and see RDD song, earlier we did 1 minus 2, top one minus second one, here second one minus top one. You can do that way as well. Okay, if it does not present all the keys in either RDD, then you have to make a list of both RDDs using subtract by key option. Okay, this is complete theoretical, you do not have to worry about it, but just wanted to highlight that it may come into your life anytime. Okay, your Spark life. Pair RDDs, guys, this I have to explain this more clearly, so I don't have time now. We are 6:25. I'll cover this in tomorrow's session. Okay, so one thing I have to come up is flat map value syntax error. I'll definitely correct it and see where the mistake is. I think the documentation what I have done seems to be a little confused one, because here they have used on the Mary had a little something and I had my Amarnath, that one. So I'll sort it out. If you have any questions, let me know. I can give you 5 minutes time. Any questions, let me know. I'm available. Anybody, any questions, let me know. This is Gopi in the class. Yeah.
Can you share this screen or the slides, sir?
Yeah, sure. I'll do it today. I thought to do it yesterday itself, but I forgot. I'll do it today.
Okay.
Anybody else? Everyone happy? Thank you, thank you, thank you. Okay, fantastic. Thanks everyone. Have a great day. Enjoy your work. See you all tomorrow. Okay, thank you.